for introduction. Hello everyone, good afternoon. So the next 30 minutes you're gonna spend with me now. My name is Philipp. I'm CTO of the company Wikitude. And I know the title initially said a tutorial to the Wikitude SDK. I switched it a little bit to kind of an advanced insight into the Wikitude SDK. So we're gonna talk about the architecture, how the Wikitude SDK is set up, what it kind of offers, and what are the probably not so well-known hidden gems of the Wikitude SDK. I'm also going to show kind of what's up next for us, next 30 minutes, and I think we're going to close then with a question and answering session. Who of you has already heard about Wikitude? That's probably 30–40% of the audience. Okay, so allow me to kind of structure it in a way that I'm shortly explaining who we are, what we do, what we have been doing, what we're not doing anymore, because that's also kind of interesting and important. What the SDK has to offer, how it is structured, what is the software architecture behind it. I'm talking a little bit about the plugins API, which we introduced last year, and again, the latest addition to the SDK, particular 3D tracking. And I'm kind of starting off with the first thing that really which was our source of everything of being Wikitude. And I kind of would like to give the question to the audience, who knows which model that is? G1, yes? Who knows which HTC model this is? It's the HTC Dream, but this was the very first Android device, right? I think that's kind of a known fact back in 2008. And if you look very close, so this is one of the official shots, but if you look very, very close, you see a palm tree at the lower row of app icons. And that was the very first Wikitude app icon. So it was pre-installed on the first Android device because we were taking part in the Android Developer Challenge back then, and we're under the top 20. That was when the company was founded. So an AR browser, an AR geolocation-based service for Android and later on iOS. That was what was Wikitude now nearly 8 years ago. The world has changed. We are not that anymore. And we're getting questions a lot about, oh yeah, Wikitude, I know this app. Yeah, it's a cool app. But actually, we kind of put aside the app business and the app development. The Wikitude app, you will find it's still in the Play Store. But admittedly, it hasn't been updated a lot. What Wikitude is now and has became in the past 4 years is a technology provider. So we've switched from a B2C company to a B2B company, just purely because our team is very technology focused. We're not kind of the marketers which would be able to commercialize a B2C app in a global scale. We know what we are. We are a technology company, and back in 2012, kind of the entire company flipped or pivoted and went down the B2B road. And so if you have in mind Wikitude, those are the guys with the geo stuff and floating points of interest around. That is partly true, this is our history, but what we've become is a full provider of AR technology, whether it be AR, geo, LBS, 2D recognition and tracking, and now later the year, 3D tracking. We're based, our headquarters based in Salzburg, Austria, right in the heart of Europe. We have a satellite office here in San Francisco. So, you know, if you want to meet us, don't have it too far, either Europe or in the US. What we do and what we sell is the Wikitude SDK. That's the core product of our company. We've been doing this now for 4 years. Additionally, we've been building services which somehow hook into the Wikitude SDK. One is a cloud recognition engine. One is an AR creator and content management tool, web-based, called Wikitude Studio. And all of them are kind of available as an API. So if you want to use your own CMS and hook that into our process, you can do that through our APIs. What we kind of are known for is that we try to go where the developer is. And in general, our SDK is available for Android and iOS, but you have multiple options to work with the Wikitude SDK, either be it Cordova, Titanium, Xamarin, but we'll come to that in a minute. Just repeating, The SDK can do geo-sensor-based AR, can do 2D image recognition and tracking. You can use the SDK on several eyewear glasses, Vuzix, Epson. We just added the ODG R7. All of them are supported and run through the SDK. As I said, I would like to talk a little bit about the architecture, and this will explain our product a little bit more. As I said, iOS and Android runs cross-platform, and the very core is our C++ layer, which includes the computer vision engine, our own computer vision engine. So we don't use OpenCV. There's no other third-party relevant IP in there. This is our own IP. It includes 2D offline or on-device recognition and tracking. You can preload up to 1,000 images and recognize them. A 2D cloud recognition hook, soon to be added into the product, a 3D recognition and tracking, and obviously a renderer. We're using OpenGL ES2 for that. That is wrapped in a C++ core working cross-platform. On top of that, there's a native API. You can use that directly for your app, building through the native API, Objective-C, Swift, soon to be announced, and Java. Based on that, there's also a Unity plugin that wraps the entire native API, and you can use Unity. Not a big thing or big differentiator here. Different though to other SDKs, we have a JavaScript API, and actually this is where we started. The native API was added last year. The JavaScript API has been there for 4 years, and that is kind of different to the native API. It actually includes other stuff than the native API, namely all the location-based services are in there. There are several convenience functions like a radar element you can use out of the box, geofencing, stuff like that. Then the things we call augmentations, so the drawables, image overlays, video overlays, 3D model overlays, and a C++-based 3D rendering engine, which you can also access through the JavaScript API. Again, you can base your app directly on our JavaScript API and write experiences through that, or use hybrid mobile frameworks like Cordova. There's an official Cordova plugin which we write and maintain continuously. You can base your app through that on that, or use Titanium if you'd like, or if you go for a C# approach and want to use Xamarin, you can do that as well. So you do have quite a lot of options to write your app using the Wikitude SDK. But that's not all. At the very bottom of that, there's kind of a hidden magic, if you'd like to say so. There's obviously a hardware abstraction layer, so camera part, an IMU part that is covered. We do invest quite some time in optimizing all the algorithms, not just kind of on a surface, but there is a substantial amount of neon optimizations included in the SDK, both for V7 and 64-bit. And we're moving towards much more GPU offloading and including an OpenCL and Metal generic framework to kind of use the best processing unit available. That package is kind of the standard SDK package. And what we added last year was what we call the plugins API. And the story behind it is that we've been approached by many different customers that want to do some sort of camera-like application and use the Wikitude SDK as well. So think of an OCR application that want to use augmented reality. Think of barcode reader in combination with AR. Think of face detection plugins, stuff like that. And while we think we could do some of them on our own, we are we're quite sure that this is not our core competency. So we came up with the idea that we would allow plugins to the Wikitude SDK, so you can build your own modules and your own plugins, and kind of can combine whatever you have with the Wikitude SDK. So if you have an algorithm software that also uses the camera, you can use that along in parallel with the Wikitude SDK. And that is all wrapped through what we call the plugins API. I'll talk about that a little bit later. Yeah, the plugin manager obviously in the core is handling all that. So as next, I would like to highlight 3 points out of that architecture in a little bit more detail, the plugins API, the JavaScript API, and as I said, 3D record tracking, and talk a little bit what the Wikitude SDK can do there. So as I said, the plugins API is a way to modularize our SDK. The plugins API, or a plugin that you can write, basically knows two types of plugins. One is what we call an input plugin, so a custom input provider or frame provider that you can write. And the second one is just a standard kind of plugin or computer vision plugin. All plugins are written in C++, and you can use them through the native API or through the JavaScript API. So basically what you do, you write your own class, you write your own C++ plugin, register it, the Wikitude SDK can work with it in parallel, and you can share things. What does that mean a little bit more graphically? So let's focus first on the right-hand side on kind of the flow diagram, not really a flow diagram, but so in dark gray, those are the parts the Wikitude SDK come with by standard. So we have a standard frame provider, a standard method to kind of capture the camera, work with the camera, and manage the camera. This frame provider provides the SDK with an image frame. And that is used in A for rendering and B for processing in the Wikitude CV engine. That's kind of the standard use case. As I said, there are two ways of thinking of plugins, or two different types of plugins. One is on the top, the custom frame provider. So we allow you basically to send us whatever image frame you want to have, or you have, and send that to the Wikitude SDK as a replacement of the standard image provider. So think of a remote camera which sends you the image data, but you want to process it on a different device. Think of a custom rendering, a custom shader you want to write. You can use that in the custom frame provider. Excuse me. But then, when we have this image frame, we're also sharing that with whatever plugin you have and want to register. So we taking that image and process it on our own, and also sharing that with your algorithm, with your plugin. And there you can do basically whatever you want. But we're also feeding some information from the CV engine to your plugin. So let's say we're recognizing an image. So we're feeding that information, which image we've been recognizing, where this is placed in the image to your algorithm, and you can make use of that as well. And the two code parts I put up there, the upper one is kind of the generic definition of a plugin, and the other one is this class recognized target, so the information that you get back. You see an identifier, you see a model view matrix, and you see a projection matrix of the things, so you can work with that data on your own. So why would you want to use it? Run your own CV-based or camera-based related code parallel to the Wikitude SDK, OCR engine, a barcode reader, face detection, face recognition, you name it. There's one company who has been using that already quite a lot. They're already also here in the exhibition hall. So if you pass by any line, say hello from them. I think we have also one guy here. So if you have any questions about a real world example for OCR, pass by their booth. It's great what they're doing. And on the second hand, you can use your own camera stream. We've implemented as a sample an own OpenGL shader or custom effects, or think of a remote camera stream that you want to process on your phone. Okay, let's move on to the JavaScript API. So when I say JavaScript API, what I mean is that you can define and create AR experiences through JavaScript. And when it says architect, this is our internal code name for the JavaScript API, so don't get confused. But a JavaScript experience basically consists of HTML files, of JavaScript files, and CSS files. And that all defines your experience. You link our JavaScript library in your files, and we inject that then during runtime. So there's not an actual JavaScript library. You just define it that you want to use it, and we then inject that through the SDK into your view. So what basically happens is that the JavaScript execution triggers action in the underlying C++ layer. So you're kind of mapping or bridging that from the JavaScript API to our C++ core. And we kind of have two views that we use. One is kind of the AR view, or the OpenGL rendering view that renders the camera, that renders all the augmentations, so all the things that are kind of moving together with the camera. On top of that, there's a web view with a transparent background that loads all your standard JavaScript and HTML files and your experience, and both of them are communicating quite a lot. Of course, in the standard web view is a WebKit view. You can do any stuff you can do basically in a web browser on top of that as well. This is an example how this could look like. I mean, this is quite old. It's geo-based, but I think it served the purpose. We have both views unified here. On top is the regular web view, actually using a jQuery library. And in the middle, you have the AR view, which moves accordingly with the user. That also means that you can use any JavaScript or mobile optimized library that you have. In this case, it's a jQuery UI. You can use Material, whatever you want to do, basically to create your AR experience. And as an example, how this kind of looks like, just 1 second. This is a simple image recognition use case. What we want to do is we want to augment this kitchen catalog page with a video. What you would define is a tracker with a Wikitude tracker file. You define an overlay, a video drawable from the AR namespace. That just loads an MP4 that you have locally and resize it to 65%. Then you combine both of them together. The kitchen string basically tells the tracker which image from the tracker you want to load, and associate the overlay as a drawable with this particular. All that code would basically render what you see then on the right-hand side. You can use and can choose from different augmentations or drawables, obviously images, videos, also including alpha channels, so transparent videos, 3D models, web views, labels, basically. That's a set you can work with through the JavaScript API. Which kind of leads me to my last part for today, 3D tracking. This is something we've been working now for more than 2 years. And while 2D in a certain way there's one solution which fits most of the use cases, 3D is kind of different for us. So we're building out the different flavors of our 3D tracking engine, and some of them are already in a state which we will soon launch. Some of them are a little bit further ahead. So we're working in parallel on that. Basically on the left lower side, small scale object tracking. That's something we're showing also today. So if you will pass by the booth, you can see a demo of object tracking and recognition. We're working on cat-based initialization and some positional tracking. And I'd like to show you real quick where we are in that respect. So this is a real quick demo of object recognition of this truck we're tracking based on a point cloud and SLAM based methods. So you see varying underground, some reflective material as well. Because I got that question already, the red rectangle is just an augmentation. It has nothing to do with the model itself. Another approach we are currently working with is CAD initialization or edge-based tracking. Here we use a 3D model, a very basic 3D model of this football as an input, and be able to track that. This is still a little bit ahead. This is one of our latest R&D efforts. But as you can see, tracking is already quite promising, and particularly in areas where you don't have any graphical or feature points, this will help a lot. And the third approach we're doing in parallel with 3D tracking is positional tracking for large areas and large spaces. I'm showing you here one of my colleagues from 2 weeks ago. We recorded that video. What you basically see is in the main window how my colleague's moving with the phone. then at the in the corner, what the camera is actually capturing, and then in the middle, the point cloud or the calculated position of the phone. This is a sensor fusion approach, so both vision and IMU. And about 2/3 in the video, my colleague is actually hiding the camera so that we kind of, by purpose, losing the vision, and you'll see it still continues to track. So, of course, this is without any tracker or without any pre-training. You basically start and then, or initialize, and then the algorithm will position the phone in the space. As you can see, we're quite good already with fast movements. So now we're at the point where we, by purpose, remove the vision system as an input parameter, and the phone still keeps tracking. Obviously, when you do gyro-only tracking, you include some drift, but for that demo, that was kind of by purpose. That's kind of our future goal for the next quarter. As I said, some of those initiatives are still early. Some of those initiatives are already further ahead. But those are the things we're currently working on, and which will come then into our products. All right. Thanks a lot for the attention and being here today and sharing those 30 minutes with me. I'm happy to take any questions. Thank you.
All right. Can I get two questions? Can I get two questions?
Sure, go ahead.
So the first one is, what engine are you using to run your JS on Android?
What engine are we running to?
What's your JavaScript runtime engine on Android?
The one that is provided natively.
Oh, so for iOS and Android both, the native one?
Yeah.
Awesome. And if the web view is an HTML view on top of the scene, which is the camera projection, then how do you make objects rendered in HTML track along with objects in the scene?
So we're syncing those two views, and through our bridge, and obviously that's kind of the magic of the JavaScript API, that we have both views unified together and correctly position each element to that. Does that make sense? I mean, basically you have the OpenGL view, and on top of the same size you have the web view, or a web view transparently placed.
Right, cool.
Question up front.
So where are you thinking the web view would be run from? Like the browser, or would we have to custom put it in applications?
Our web view is a standard WebKit UI web view that we include and that you can run. That gives us also the ability that we use all the features that are there. And as the web views are getting better, the inbuilt, the native, the better it gets also the SDK in that respect. Yes, we have, yes and no. I mean, we do have a project, or had a project where we exactly tried that. Some parts of the API are already transferred to a pure browser implementation. Some of them are not yet there. But yes, this will work, yeah.
With that tracking that you showed, how much CPU usage does that do to do both the RGB and IMU fusion?
I mean, we're at the phase where we kind of jump to the mobile now. Basically, that it runs on the mobile phone alone. Of course, CPU usage still is quite high, but our embedded vision group is taking over that and is kind of trying to get it lower and lower.
Like ballpark, like single core, or 50% of a core, or what's the target?
At the moment, we're maxing out the CPU quite often.
I see.
That way. But I mean, that's not an issue yet for us, because we already know that we can optimize that.
For your 3D tracking, do you need to also save the 3D points in your device?
So the truck you saw, that is based on a model or on a map which you pre-record. We have a recording process or recording algorithm which we expose to you. You do the recording, create a map out of it, and then you load that map as a reference.
So what's the size of the 3D points? The data size in the device?
So depends very much obviously on the device. As a rule of thumb, you can say an object has between 3 and 5 megabyte, roughly.
Okay, cool.
Any other questions?
A little slow filling.
Hi. I work within the UK to support education in universities and schools. It's a great toolkit, and I've used Wikitude since you first started, having used various others like Layer and Mataya at various points. My only concern is with the education market, there's not as much money to spend on developing content. So because the industry is quite fragmented at the moment, if they were to outlay significant funds, they would need to know that they were going to be around and not just bought out next year like Mataya were. Is there an education-based kind of model that you have that is different to, say, an enterprise model in terms of licensing?
Yes, so there's an education program, and if you're more interested in details, then we can talk afterwards. But there is a separate one. If you're using it purely for educational purposes, there's a program, yes.
Great question.
Welcome.
Okay, so round of applause, please, for Philipp.